since I'm on call this week, I've been, we're not saving babies, and like, so I was kind of wanting to just chat about fake babies or the on-call calls that we've been on that feel like when you think about like your life and you think about like what you're doing and like it just really like trying to like justify. I don't know. I think you know this. I'm on call this week, sort of getting back into that product engineering headspace. And so I'm on call this week, and I had a call that went 12 hours or so.
Oh my
Um,
goodness.
the first time in a long time, but Steph reminded me that in the old days at USAA, I would get calls at like 1 and 2 in the morning and then
Yeah.
just be online for like, the same amount of time, like hours and hours and hours while you sort this out in this huge megalithic like ecosystem. And I'd sort of like let myself forget that. I do remember some instances of like being like taking a call late Friday night and it basically not getting off the call till like Saturday afternoon. Um,
Yeah, you were mentioning like fake babies. And I was like, what the heck are you talking about? Fake babies. And now it kind of makes sense.
yeah, like it's not a real baby. Like I'm not saving an actual baby, right? Like I like it's like this, we've got to save this baby, but really it's like um maybe we just turn it off and on again. Like you can't turn a baby off. I mean, I know that you know there are times when I'm like, oh, I wish you came with an off switch. Um
I needed to be reminded for a minute what this podcast was about, so thank you.
ah, yeah, it's like we're not, yeah, so that was my thought is like just like, you know, I don't know. You remember I used to work in the like networking and call infrastructure portion of USAA. And like I remember Cisco, just like we could just like point the finger at Cisco. It basically would always go down. And then if people hadn't built their services in a way to like be prepared for Cisco to go down, like you'd have this error propagation through the whole system. Because their error would propagate, or they would get an error because they weren't prepared for Cisco to go down, and then whoever was calling on them would get an error, and then you'd have these huge on calls of like, but it always gets surfaced in the weirdest way. Like somebody
Right.
way over there would be like, "Oh, I'm getting your service isn't returning the data to me."
Exactly.
That's all you would get. You would get your service isn't returning the data to me. And so then you start to like, so I would spend like, I'd be on these calls for like hours unfolding this chain of network calls all the way back to like Cisco ingest and being able to say like, oh, well, our Cisco like is not emitting the events that it's supposed to. And I learned a lot from that about like, um, you learn a lot from like how to manage, like I think standard you learn to manage a request, right? Is the request correct? And if the request is correct, I go to the database and I get some data and I give it back to you. That's sort of like standard engineering. What I think I learned for like my time at USA, and part of this was, a frequency of that was that like if you have shared data, like you can't trust the data in your database to be like well formed, and so you have to be defensive in your engineering even of data extraction from the database, because somebody could just have shoved like garbage data in there. And there's a lot of arguments to be made in that ecosystem for like microservices and total data ownership and stuff, and I think we could make those arguments, but like I think that was the thing that I took away from like having to unfold this, because eventually that's always what happened. Is like you're like 15 hours in to this call or whatever, and you would realize that like, oh, well, what happened is because some other service was down, your service just passed me junk data. And so then when I tried to pull out, like I worked in call scheduling, right? And so when I tried to pull out like scheduling rosters from the database, like I had like 10 rows of gobbledygook, and so my service fell over. Like, and that would be, and so the situation was always like, okay, well, let's sanitize that data and get it out of there, and then the services magically back up and everybody's working again.
Yeah. Well, it brings up at least two things to mind is one is having like early identification, right? It shouldn't have been until the person at the very end,
Right.
or the client at the very tail end, couldn't get what they needed before we started to realize that something was wrong, right? So like early identification. And then I also think about like surfacing, and having controls at like the appropriate levels. So like if the first layer that consumed that Cisco service, right, or
Yeah.
whatever it was, if it got back, it should have had checks in place there to say, hey, this doesn't match our schema, right? This doesn't match what we expect. A
Right.
simple assertion. is this what we expect? Or is it in the shape of
Right.
what we expect?
Yeah.
And it doesn't have to go like super deep. Been at companies where they over engineer the heck out of like schemas and like everything's, I mean, just give me something that just doesn't match the shape,
Yeah.
right? Is it there or is it not? That would have been better than nothing and finding out later, just simply passing the error on, right? So there's a couple things that you can do there, but of course we don't necessarily want to get into the weeds. But if you're on a call, what'd you say, like 12 hours?
Yeah. Yeah.
I mean, come on, that's excessive.
I mean, that's the baby, like, because you're doing surgery on the baby, like,
Yeah,
and yeah, no, it's definitely. I think that there's a like, and there's two kinds of issues here. I mentioned Cisco because that one's really interesting. It's a third party integration, like a deep integration, right? And then there's like, I don't know. What I guess I want to say is like, I have always been a strong advocate for like a rollback first mentality. And I would hope that we are building ecosystems that resolves 99% of issues. Just roll it back. But
right.
I'm also fully aware that there are issues that like can't be rolled back. Data sanity, third-party integrations, like you can't roll that back, and or things like network, like your networking layer, like if the networking layer is broken, like you can't really roll back your network. I mean, if somebody knows how, that'd be an education point for me. But like I wonder though, like to your point, like 12 hours, like at what point do you just cut your losses?
Right. Well, I don't know the details of what happened, but I do think about like, are your systems as robust as they could be? Right? Are they
Mm-hmm.
preparing for failure? Right. So
Right.
we both know Jacob works at Gremlin, and that's exactly what they do. Chaos engineering. It's about
Mm-hmm.
in advance to an actual failure, testing your systems and testing your systems in ways that you wouldn't normally test or expect. Now you don't have to go to that extreme. Not that that's an extreme, but you don't have to go to that extreme and be like, oh, we're gonna, bring in a chaos engineering expert and we're gonna do all this stuff. But even just thinking about your dependencies,
Yeah.
this integration, this third party service. So like AWS, right? It's rare, but AWS will go down, right? They're not
Mm-hmm.
perfect. They'll go down
Right.
because they also have dependencies. They have hard dependencies on like physical infrastructure and things like that. GitHub will go down. Um, And so you want to have stuff in place that says, first, you got to identify your dependencies. We have a dependency on AWS. Okay, what happens when AWS goes down? Do we have another provider that
Yeah.
we can simply switch to?
Like
Right,
fell over to, yeah.
right, fell over and route traffic to that. And then when AWS comes back up, then we route traffic back. But it's being like proactive in these things. And the worst thing is to be reactive, meaning all of a sudden all the alarm bells are going off. We're broken. You
Right.
can't just go in there and just start like resetting everything, right? Because again, it's like you're working on this baby and you've got to be real surgical about it. Well, where's the actual problem? Because you don't want to, contaminate your data or destroy it at that point, or have or create bigger problems, right?
Yeah.
Like so, you want to be real surgical, real methodical, and be like, okay, you're trying to find out what the root cause is, and it can take a long time. Like I remember when I joined a company not too long ago, which I won't name. Almost immediately I was on like calls on Friday to like eight
Mm.
o'clock at night. And I'm thinking to myself, what are we doing?
Right.
And we were working on something that wasn't even in production yet. So we were working on
That,
a replacement system, a system to replace the current system,
mm-hmm.
and things would break in it. And it was just bananas to me the way that this system operated. It didn't have any like real controls in place. It wasn't built modularly, right? If one thing failed, everything failed.
Yeah.
And so when you build stuff like modularly, or maybe if you chose the microservice pattern, which I actually prefer, I know some people like hate it. They're like, oh, monoliths all the way. It isn't, it's just an opinion. But
Yeah.
I actually prefer that because then I can isolate it and I can say that's a dependency.
Yeah.
When that service goes down, maybe I can have some cache data and I serve up some stale data,
Yeah.
right? And I can treat that as a separate, right, isolated dependency. But if you build everything together, again, that's a little different. You can still have some caching mechanisms in place, but it's really not like how you do the specific thing. It's just being aware that we need to do the things.
Right. I love what you're hitting on. The first, like, the thing that you said, I'm gonna just loop back to that, is like early alerting. like goodness, like that'll solve, I think, on an on call, like having alerts that will actually communicate like there is a problem at the cause of the problem is so important. Now, obviously, that's a lot of times that's after the fact, and just human nature. We kind of like look at something, we're like, okay, well, it works, and that's I think gets to the second point. Is like we're like, okay, it works, and that kind of leads us away from the path of like thinking about like, well, how will I know that it's not working? It's sort of like the Jurassic Park effect, right? Like we count all the little the female dinosaurs, and there's just as many dinosaurs as there are supposed to be, and so we don't think about like, well, what are the chances that there are any non-female dinosaurs? We're like, no, there's no, they're all girls, and then but lo and behold, there are some not girls roaming around there. And so like if you're only counting to make sure that you have enough the dinosaurs that you expect, and you're not just counting all of the dinosaurs and trying to match them, right? You leave yourself. So it's a little bit about how we build our observability.
Yep.
Do we build it to just check for the expectation, or do we build it to report on the reality? And so I love that. And then like kind of that leads to the second thing that you're talking about is like making sure that like we build in such a way that we can I like your isolating failure. I usually say reduce our blast radius, because when things blow up, right, I just wanted to like
Yep.
this one little thing falls over, and then you have a lot of options. Like you're really hinting at like the SRE mindset or the SLA mindset that says, hey, my service has an uptime responsibility of X. All of my dependencies can have their own SLAs and their own uptimes, but I'm responsible for building in such a way that even if they go down, I can maintain my uptime.
Right.
And like having that, like starting right there saying like, what's my uptime? Like I think that that's a great exercise for starting any new service project. Like what's our uptime requirements? Because one, that should influence your architecture. It should influence how much caching you're doing, whether or not you have to do real-time data streaming, or if you can facilitate like eventual consistency, stuff like that. Those are all fantastic things that really can be driven by what's my uptime requirement, and then what are my dependencies? Because now I've got to be able to, like you said, like build in such a way that if my dependency goes down, like one, either I'm reporting it, like what's better than one alarm is two alarms independently going off, because now I can triangulate the problem, right?
Exactly.
um so I need to be able to alert on that, but I also need to know like what is the resiliency of my service, like sort of chaos engineering. What happens if AWS falling over is such a great example, because like that's catastrophic failure for many sites. Like that's it. That's the end. Because you and I talked a little bit just briefly about this recently, but like the value of like a deep integration versus a bespoke like architecture. I favor sort of a bespoke vendor agnostic architecture. But if you're deeply integrated, like, and your vendor goes down, I mean, that's all the chips are on the table, right?
Yep. And only you can know how much, revenue you're losing like per minute,
Right.
right? Per minute of downtime or whatever, however you want to calculate that. And so like for some companies, if you imagine like if Amazon went down, they're probably losing like $1 billion
Oh yeah.
or
Oh
something
yeah.
in a day or in a minute. I don't even know, but it's the e-commerce trend is just it's on another scale, right? Compared to other companies. So even somebody smaller though, right? Like if you're trying to get off the ground and you're making, chump change, right? Like you're making $100 an hour or $100 a minute. That's a lot to you,
Mm-hmm.
right? Because
Right.
that's what you need to survive, right? That's what you need to be able to reinvest. So even early on, we do want to like identify dependencies. And that's really what it comes down to is just we can't, just think, oh, AWS is the magic bullet, right? GCP is the magic bullet, or Azure is the magic bullet, right?
Right.
We're gonna go to them. They're a big company. They've been around forever. They'll never go down. And that's really not the truth because we've seen it happen recently.
Yeah.
And so it's more about like taking these steps ahead of time, knowing when to take risk. Like I can take a risk here, but I don't want to take a risk here, right? And then also understanding like what needs to be real time. A lot of stuff doesn't need to be real time,
Yeah.
right? And then even if something should be real time, but the checkout service goes down, you can start to get creative and say, well, what if I could tell my user that we're down right now, but we're gonna keep all these things in a basket.
Yeah.
And as soon as we
Exactly.
come back online, we're gonna let you know so you can continue the checkout. Right. And so you can get real creative to say, okay, if this goes down, but it requires that forward thinking mindset. We have to think when this happens, not necessarily if it happens, because that's not the truth. It's when this happens, how do we respond?
Yeah.
And I think that's the mindset that, I mean, you've seen it, I've seen it. A lot of startups don't necessarily take, and you can just ask the question, how robust are we? How resilient are we?
Right. Yeah, I think, and we Amble just went through an exercise very similar to this, kind of on accident, right? But it was a worthy exercise, and that's like if your whole ecosystem goes down, how long does it take you to stand it back up from scratch?
Right.
I mean, fortunately for us, it doesn't take long. Um, but that's, I mean, a question. And I think the real thing that you're emphasizing here, though, I come back to is like these things can feel like extra overhead when you're trying to architect something out or build something, but they pay dividends when something breaks because then those 9-hour calls end up being 30-minute calls because you know exactly what the problem is and you hopefully also have a means to mitigate it. You know, like that's like, oh, my third party service is down. I just built this amazing new feature on chat AI or what's it called?
OpenAI or ChatGPT.
OpenAI, yeah, ChatGPT. There we go. Like OpenAI. I just built this amazing new feature on OpenAI, and now OpenAI is flooded with traffic, or I've exceeded my tokens or whatever.
Right.
And then hopefully your system does two things. One, it alerts you, hey, I can't do this service anymore or this part of the app anymore. And that feature seamlessly disappears from your application. So like literally the solution is do nothing. Like that's the best response to a notification is I need to do nothing because the system will handle it. Um,
Right.
that's yeah.
Yeah, I was gonna say, that OpenAI API, it's kind of low, but if you start to have lots of traffic, it's gonna eat you up. So
Yeah.
immediately I'm thinking, right? Like again, immediately I'm thinking, how can I cache some of these responses from OpenAI? Right?
Mm-hmm.
I'm immediately thinking like future. Okay, it's not a matter of, if, but when my traffic picks up a little bit, I don't want to get hit with this massive bill.
Right.
So what are some of the responses? Maybe some of the more common responses based on the domain or the problem that my application or SaaS solves. Then I can cache some of this. Maybe I could have uh, maybe a local implementation of the model
Mm-hmm.
in my own server running, so I can start to move off of OpenAI's API, and I can leverage them for some things, but more and more things I can leverage my own model and have it there, right? Because you don't want to be caught with those things. I think a lot of times we just say, oh, here's an API, I'm going to sign up for it, and then we go for it. I remember, and it still happens to this day. Some companies will get hit by these big old massive surprise like AWS bills,
Yeah.
right?
Firebase.
Like $100,000 or like $500,000. And like, where'd this come from? And it's because when they architected the stuff, they're like, okay, AWS makes it real easy. And I'm just picking on AWS, but
Yeah.
the same thing could happen for Azure or GCP or some other provider. Same
Right.
thing can happen, but you can not think ahead and you're just like, oh, we're just going to call this API. And your client calls the API, and then maybe you have a bad actor come along and they just spam your site. And
Right.
you're like, now all of a sudden you owe this money. Anyway, I wanted to talk about risk right quick.
Yeah.
Like you were just on this call for like 12 hours. You know, when is it acceptable to take a risk? Like in what spaces of your application or of your system?
Yeah. This is a great question because we took some measured risks in this thing like you I think the longer the call goes on and the more clear it is that there is not an intuitive or obvious fix to the problem, um the more inclined everybody gets towards risk, right? Like it's like, well, we got to try something. We have to do something. And something, first of all, I'll say that like every site should have a maintenance mode because like sometimes that's the solution. You're still losing money, perhaps, but you've mitigated some portion of the problem so that you can figure out a good solution. Um, so being able to put your site into maintenance mode, if you notice a problem that is there, like the you can do that. But as far as like when are you willing to take a risk? I think like part of the answer to your question is like how robust is your testing ecosystem? Do you have a secondary environment where you can roll a change out and see if, like, I think the shift here is, does it, like, you go from, at some point, you go from, does it fix the problem to, does anything break if we do this? Like, because you're not sure that it's going to fix the problem, but it's a problem anyways. And maybe it's like there's too many, like, how these systems can be. Sometimes there's too much noise. And so it's really hard to like filter down to what is the problem. So you're like, okay, well, look, this thing over here is emitting 500s. How risky is it that we just like we fix that part? And like maybe that fixes everything. Like remember that call chain all the way back to Cisco. Like like halfway through, you're like, what if we can just stop it right here? We don't have to get all the way back to Cisco and fix things. We can just cut the pipe right here. Um, so the I think levels of risk, like one, do you have a place you can test it? Like making changes in production? Not, I mean, I'm not going to say I've never done it. I mean, I did it at enterprise. Like we made changes directly into production and then back patched them. Um, so I'm not gonna say like never, because that would be hypocritical. I could tell some stories of logging into uh pods and making changes directly to the pod. Um, but I think that that's much more risk prone than but I guess like I think the answer to risk is, what are your options? Like how much risk are you willing to take on? Is like what other options do you have when you run out of options? Like you take all the risk, uh, because that's the only choice you have. And so yeah, I've like to that end, like we didn't have an option to fix something, so of course we logged in. And again, I've not been I've never worked anywhere that I didn't eventually need to make a change directly in production. I mean, and I say that, um, I mean, I've been doing this long, but yeah, I've never worked somewhere where I didn't eventually need to make a change directly in production.
I think that it also demonstrates a level of confidence, right? Like um, at a point, we want to completely understand our entire workflow and an entire pipeline. This is something that I'll call out, like when I was a junior engineer or early career, etc., um, and others. We don't always understand the implications of what we're doing locally and how it actually makes it to production and what's
Hmm.
actually running in production,
Right.
right? So we saw this recently. Somebody's building a React app and they've got this automatically connected pipeline that deploys it, right? And it's like, well, it
Hmm.
worked locally, but it doesn't work, you
Right.
know, in quote unquote production. This service, right, that somebody's offering that allows me to host my site. And if we don't understand how this locally in development changes or is converted or compiles or transpiles, and it ends up becoming that thing that actually ends
Yeah.
up being consumed, if we don't understand how it gets there and the transformations that happen and what's actually there, then going to production, logging into that production box does us no good, because we're
Yeah.
simply looking to do the same thing here that we're doing there, but that's not the case. And
Yeah.
so that's a huge part of it, right? So the I mean, I did the same thing. I think I won't call the company out, but I've done it a couple of times too, where yeah, you log into production, and then this is one of the reasons that I always tell people when they don't know Vim, right?
Hmm.
When they don't know Vim or VI, right? I'm like, this is why. This is
Yeah.
why you learn Vim. So when you're on the box, right? You're on a Linux-based box, you can edit on the
Yeah.
box and you know what you're doing without having to install this fancy editor. You make a change to the file and then bang, you're good to go.
Right. I love that the thing that I'm thinking the most about, of course, is that I remember the first time, like what you're talking about, that I logged into a box where an asset had been deployed. And lo and behold, Ram, the code is completely different code than the code I had sitting on my local machine. Of course, because it goes through layers and layers of obfuscation, minimization, triangulation. Like it goes through like a quantum realm and comes back to me as
Yep.
a completely different set of
Through the
code.
Bifrost, right?
Yeah, exactly. Yeah, exactly. And then it's like, and so like I log into the machine and like I'm looking for like my index.tsx or whatever, but it's not there. It's not there. There's some random like main.hash.js sitting out there. And trying to like make a change into that directly into that file and like figure out like, what's going on here? I just need to turn this one little indicator off. And and finding that in a compiled code is a much different exercise than. And so some of that is, you know, making catching errors early is less costly than catching errors later, because changing code in that secondary file, that artifact, is much harder than changing code in that in your source code. um but also, to your point, like, there comes a point when, I mean, sometimes you have to read it. You have to read that gobbledygook. I mean, maybe it's because you're reverse engineering something, or trying to reproduce a problem, and so like you needed to like extract a bundle and rebuild that ecosystem kind of locally to figure out what was going on. But at some point, yeah, you like, so knowing like what that transition is and what it's like is absolutely very important.
Yeah. Coming back to risk, I think this is really important, like to get to an understanding, um, because we over like, and I'm gonna come back to this over and over and over again. When you're early, you don't know all these things. You don't know if this is a risk that you should take, right? We have
Mhm.
like this capacity of risk. You mentioned before, like we have this capacity to care. There's very similar with risk, right? Like you have a risk appetite.
Yeah,
How much risk am I willing to assume? And if you only have so much, where do you assume it, right? And so for me, it ends up being, um, if I'm going to assume more risk, it's going to be in places that aren't like a security minded space,
right,
or a place that's going to affect my user data, right? So I'm going to protect my user data at all costs. Okay,
right.
so over here I'm not going to take any risk, or very little risk. Um, and maybe over here, right, I leverage a third party solution, or like with payments. Okay, so if I was
Yeah,
building an e-commerce site and I needed to accept credit card payments or other types of payments, well, I want very little risk. I want another company to own that risk. So I'm going to leverage something
exactly.
like Stripe, right? And
Yeah.
let them assume the risk. And I'm going to rewrite the terms. And maybe if this credit card data gets stolen, it's not on me, it's on them. They're going to assume it. So in that
Hmm.
case, I let them assume the risk.
Right.
But if it comes to, um, the actual application being able to, like if I was selling t-shirts, right? The selling t-shirts part might be on me, like the t-shirt quality.
Right.
Maybe I have the sizes mislabeled, or I sent you the wrong one. That's on me, right? That's the risk that I'm going to assume, but I'm not going to assume the risk of login, right? So when
Yeah.
you log in, I'm going to leverage a solution that's, tried and true. Same thing with payments. But
Yeah.
if it's making the t-shirts, that's on me. I'm going to assume the risk there, along with like putting it in the mail, sending it to the right address, etc. And so we have to really think about, like, where does it make sense to take risk? Where does it
Right.
make sense to offload the risk? And you can see this with some companies, like when it comes to like upskilling their folks, they can build an in-house training program, but that means that they assume the risk, right? Because we've
Right.
talked about something called like owning your own talent pool. It's the
Yeah.
idea that uh the market's quite a bit different today. But go back like 3 years ago, when the market for engineers was really tight,
Yeah.
and companies were fighting and for talent, especially for senior talent. And then, the pay scales keep going up, right? Salaries keep going up. And so we talked about this before, was that some companies will say, okay, well, it's getting difficult to hire from outside. We can grow our own talent pool.
Right.
But if you do it in house, you assume all the risk, right? You
Correct.
hire
Yeah.
somebody, and then if they don't really fit, they can't really do the job, then now you have to either fire them, or you have to deal with other stuff. But you can offload the risk to a
Hmm.
company that does upskilling. And then if they meet those requirements, then you bring them on board, right? So you think about where risk makes sense. Um, I'm telling you, like, this is something, risk, like the whole space, is not something I would have considered 3 years ago.
Yeah.
Something you kind of learn into.
I mean, I'm really impressed with like just even that, like what I think I took away from like that whole thing. I think at its core is like, first of all, risk is not just a technical conversation. Um, like you mentioned, like risk and like owning your talent pipeline, and that, I mean, I don't know. That's pretty awesome to me to think about. Like I'm sort of digesting it still, like the idea that like you do like I mean that's why you work with like we know like some companies work with boot camps or other like in training because they're offloading that risk, right? So risk is I think that's really important to call out is risk is not just a technical conversation, it's organizational risk, right? And like you want to bias your risk and reward, right? Like that's really it is like bias your risk to where it makes sense for the rewards. And then the other thing that you called out is like not all risk is created equal, not just in like if I were to say like Ram, how much would you risk data leakage? I think the answer is it depends, right? Like you want to say like no data leakage, but it's certainly much less or much more important that there's no data leakage around the two things that you talked about, like user info, payment info, right? Like the answer to the amount of risk you should be willing to take on there is zero risk, right? That stuff is super important. But
Right.
if it's like, oh, I risked my like inventory, like maybe that's a little more okay. Like, and somebody scrapes my that because I'm the only one that is hurt by that risk, right? Like, and I think that's sort of like when I calibrate for when do you take risk, it's like, well, what's the blast radius? Am I taking risks on the behalf of others, or am I taking risks on behalf of myself and like myself as a company? And what I mean by like others is like you mentioned, like payment data, like user info. That stuff leaks. Like you make risks in those places. You're making a risk on behalf of your users. That's never a good model, in my opinion. Like make a risk that like the only person negatively impacted, or the more you can narrow the negative impact to the individuals that are capable of being deciders on the risk, the better off you are in terms of defining your risk. But I also so I thought that was really um really well stated that like there are areas that you just absolutely don't want to take any risk all like it's by domain. I think a good model is assessing impact and like the relationship between like people impacted and decision makers, because if the people impacted are not the decision makers, probably the risk is disproportionately biased, because of course if it doesn't affect me that much, I'm probably going to be more prone to taking a risk, because it doesn't feel like a risk. But it's somebody else's risk, Um, it's like what you drive, like, do you drive like you're driving somebody else's car, but you drive so it's a sports car, so you drive it a little faster, or do you drive it like more carefully because like you're taking a risk on the behalf of that person? And I think that's at the core of it. That's a trust-based relationship. Like, how do you build trust? But I think the other thing that you called out is like risk is not a technical conversation. It's an organizational conversation. And everything is like there's two types of risk, right? Like you have the sort of like risk inherent to the domain. This is kind of like complexity. You have the risk inherent to the domain if you're working in like both of us right now work in patient patient stuff. There's an inherent risk to that domain. There's an inherent risk. We've both worked in banking in the past. There's an inherent risk to banking. um, Basically when you're messing with like the core parts of a person's life, there's an inherent risk, and so you're probably less prone to taking risks in those domains. But there's a second type of risk, and that's like the organizational risk that is, it's not inherent to the business that we are doing, it's inherent to the way we are doing business. And I think that that's where like if I mean that's where you have all of your risk investment. And I think it's really brilliant to point out that like everything has a risk profile, and as you have to decide like, do I want to own my own talent pool, or do I want to offload the responsibility of keeping people up to date and upskilled? And there are trade-offs there, right? Because like there's a risk to that as well.
Yeah. Lots of talk of risk. You mentioned like, with people's lives and things like that. And so I wanted to call this out just because it's what's happened, right? We heard about this submarine
Yeah.
that like five people lost their lives, right? So we're not making fun of it. But this is an area like this is a great like reminder of the risks that we assume. Um,
Yeah.
I don't know all the details, right? But this small manned submarine, um, we can assume that maybe they took more risks than were necessary. But even if they didn't, it's the idea of that we really contemplate the risks that we take, especially with what domain we're in. What are we doing,
Mhm. Yeah.
right? And what's the consequence?
Right.
Well, is the consequence that I lose $100 in merchandise, or is the consequence that we lose people's lives? And
Right.
that's the difference.